Hey everybody, thanks for having me. Really excited to be here. Thanks for skipping the donuts to show up on time. And we'll get started here. Einblick is a collaborative space for analytics. So if everyone here is familiar with idea boards, kind of taking that into the data science space. So just to motivate this a little bit, before we get into some more practical demos, this is actually a vision video produced by Microsoft in 2015 about how maybe interaction should work in the STEM fields. You see these folks kind of dragging and dropping, working interactively. And at the end of the day, data science and all of STEM is an interactive, collaborative exercise. Instead, kind of data science today looks a little bit like this. Coffee and sad face included. So the real thing is that today we have a set of really good tools that do one thing well. So notebooks, know them, love them, use them every day. They're really good for producing complex workflows or even simple ones, but they're not really designed for sharing. And if you build a notebook, really your stakeholders are not going to be able to comb through that and say, oh, I actually can take a look at this. BI tools, they're actually really good for your stakeholders, but they're kind of like building a castle or a fortress. You put one up on a hill, you want to know how much sales was last week, every single week, and you put some effort in up front, and you have this thing that guards Baltimore Harbor against the British or something. But it's not so easy to build up iteratively, and it's not for strategic analysis. Finally, you have these tools that are actually designed explicitly around collaboration, but obviously you can't do math on them, or you could do long division if you wanted. So really, what that means is that the collaboration model looks something like this. Data engineer sends an email to the data scientist, hey, the table's ready, good luck, dude. Domain expert says, here are a few bullets about what I know about your data and what's going on with this, good luck, dude. And the data scientist goes off and works in their notebook and then produces a PowerPoint and then goes off and presents that to their stakeholders. And on slide 19, someone says, oh, actually, we eliminated this segment. Domain expert forgot to tell you. And then you go home and you're a little bit sad, and then you work on it a couple more days, and you come back with a new PowerPoint. So what if we could put that into one interactive environment? And what would it actually take to do that? So Einblick was actually born out of a collaboration between MIT and Brown universities studying human-computer interactions. And the thought process was like, hey, if we could combine all of these people into the same workspace, we could make the idea that data science is a decision-making process real. Decision-making is a multi-stakeholder exercise, and to silo each of those steps in a different tool with no place to collaborate except for the Office suite doesn't quite make sense. So Einblick is designed around being fast to facilitate conversation, but also designed to be integrated with all of the systems that you already know well. So that means connecting directly to Databricks, connecting directly to even Parquet files at CSVs. And then it also allows you to use a combination of code-based operators, Python notebooks, and also no-code operators like visual drag and drop in order to facilitate this collaboration. So what does that entail? What kind of research went into building this? So first of all, as I alluded to, we needed to change the user experience. Notebooks are really good for organizing a linear workflow, but when you have those early conversations with folks, you need a different interaction experience, and maybe that's about a more visual approach to data analytics. So whether you're in person or remotely collaborating, Einblick is a space where multiple people can join the canvas at the same time and interact with outputs in this visual way. And you'll notice that a lot of the operators here look like they're also no-code, even though we support Python fully. Then we realized that you can have this kind of visual workspace, but the reason the reason why a lot of tools are not collaborative is that they do not progress at the speed of thought. So this is a very fancy image that describes something we call the Progressive Computation Engine. That's just a fancy way of saying that whenever we looked in the past, every time you did research on human-computer interaction, if you needed to wait a second for results to return, people get impatient and say, let's take this offline. What we're preventing you from doing is to say those words. So instead, what we do is we say, oh, I actually want a histogram of salary. So if I can actually process my data chunk by chunk, push down sampling to the database, or do some smart sampling operations over flat files, I'm actually able to iteratively move through the data set chunk by chunk, update that result. And actually, that's a process that works really well for things like histograms and averages, where you should believe the law of large numbers, it converges very quickly. But even for things like AutoML, where we're searching and tuning hyperparameters, starting on a sample and growing that sample and updating our understanding of what the model looks like, starting from a small sample to a large sample also makes a lot of sense. We can apply that same approach to Python and complex data transformations, where there's no reason to actually eat a whole hoagie by shoving it in your mouth and then chewing the whole sandwich at once. Instead, what we do is we take a bite, and if you're doing a row-wise operation, you can just run your same Python script, in all the favorite libraries, everything, and it moves through that progressively as well. So all of this is a process that we call progressive computation, but really what it's saying is that you can start working and having a discussion off a sample, and then keep progressing, and that calculation will continue to run in the background. So here's just a quick example of what that looks like. So we went on a medium-sized machine, a 30 gigabyte data set. It's not the biggest in the world. And what we show here is that within 400 milliseconds, the first result has come back. And as time passes, you'll see that the chart on the left will continue to change and re-render itself, and as the chart on the right is just calculating all in the back end at the same time. So this video is going to speed up, and we make this claim that in 24 seconds it calculates. And you see that there's a little bit of animation because those bars are actually going up and down. But for the most part, you actually, in a simpler analysis, you would actually only care about what bar is the highest and how maybe the top 5 rank order against each other. So rather than waiting 5 minutes to wait for this whole data set to process into a histogram, you can actually get the result 24 seconds in rather than 6 minutes in. Finally, what we do is offer you some acceleration tools. 2022, no one should be hand-tuning hyperparameters. That's not the special sauce of Einblick. That's much more an efficiency tool. When we go and have these conversations with our stakeholders, I want to end my session at the end of the hour with a prototype model. I want to know what are the top drivers. And some things like interactive key driver identification or automatic machine learning helps me get to that point much, much faster than if someone needed to watch me tune the number of leaves in my tree. So why does it matter? Ultimately, it's about productivity increase. We did a user study with about 21 folks, and they all had at least 1 year of data science experience and existing Python knowledge. We asked them to solve the same task 3 different ways, and we randomized the order in which they started solving those tasks. And they had to do a data ingestion. They needed to do some light transformation, some visualization, and modeling. What we found was that using this kind of hybrid code, no code approach, where you're using Python to kind of do the steps that code allows you to do, which is everything, but then using things like AutoML and other acceleration tools, visual computing, you actually get a significant performance benefit, even for folks who have already learned how to use these techniques. And part of the concept is code is not the important part of data science and is not the unique important part of data science. It's the knowledge and the expertise to pick the right thing to do and understand where you want to go with the workflow. But tuning hyperparameters itself is a tedious, painful exercise that is best done in 2016. So some more charts here about how much faster it is. But I will keep moving here to quickly demo to you. Before I do that, Tim Kraska, who is a co-presenter, made a lot of this presentation, could not be with us today, but he is teaching a class in case anyone is interested at MIT. He's a professor at MIT, and I'll just shill his class a little bit, 1 second, if anyone's interested. And now we can jump into a quick demo for the rest of this time. If you want to try it yourself, it's actually free to try out. We don't collect credit cards or anything. You can just use it yourself and see how you feel about it, give us some feedback. Also, feel free to email me for any information. My email is just py@einblick.ai. So jumping into the demo, what you'll first see is that Einblick is embedded on this kind of idea whiteboard that you might be familiar with in other tools. When we focus in here, you'll see that I have a relatively simple query. I prepared a data set about 1 million rows, which is not the biggest data set in the world, but it's not trivial. And from here, I can just write the query directly in here. And you can see that I was connected to Databricks, but we actually can connect to a number of source systems, whether it's your Parquet files, you can upload a CSV if you want, et cetera. From there, I was able to drag out a table, and you'll see that that table is visualized here. If I wanted to visualize a column, like my target here, there's acceptance variable of this promotional offer. I can drag that column out, and I see that I have a histogram that shows. As well, I can drag out maybe a different column, the incentive that I offer to folks. And if I wanted to interactively explore with this and say, hey, gee, did anyone accept my offer when I gave them no benefits? I can just collect that bar and drag that here and see, nope, no one accepted the offer when nothing went on. At the same time, I alluded to the fact that this is interactively code and no code. If you needed to do some pre-processing, what we offer is the ability to kind of just use this Python chunk. And here it's a trivial statement, but this is the equivalent of a cell of a notebook. You'll see that comes out here. And we're actually able to continue here to maybe do some data profiling. And so seamlessly, you can go from a code-based notebook chunk into some data profiling like you might see in Pandas Profiler. So here we can imagine that scenario where we're having that hour meeting, the data engineer finished their data set. We want to bring the data engineer, the data scientist, and some end stakeholder into the meeting at the same time. And what we're going to want to do is there's some sense checks that you can say, hey, there's a max age of 300. That feels wrong. Can we check our source data set? But there's also some other pieces of information that is encoded in the experience of actually doing the marketing promotion, like incentive ranges from 0 to 2,000. Is that correct? Does this distribution make sense? Actually, neither the data engineer nor the data scientist should be expected to know that right off the bat. That's actually experience that's encoded directly within the expert. Or take another situation that we recently were part of, working with a chemical manufacturer to kind of detect anomalies and preventative maintenance. Somebody's job was to look at this panel of dials every day for 20 years, and that person has a lot of experience to say, hey, I actually know that when this pressure sensor goes up to a certain point, I press this red button, everything needs to stop. That kind of experience needs to be re-encoded into the, the model building and the data science process, but being able to do that must happen in a kind of interactive way, and seeing is believing a little bit here. From here, we might go on to other things like kind of exploring correlations. So I just want to highlight a couple of acceleration tools. So we have a target variable here, very simple. And we can say select all. And we can take a look at the correlations. And then from here, someone might tell me applied online, applied at dealership actually are leaking information about the acceptance variable because that's something that happens after they accept my offer. So with that knowledge in mind, when I go to build this model, I know to ignore this very highly correlated variable. By the same token, incentive makes sense that how much money I give you to accept my offer will influence whether or not you take the offer. We'll jump forward from here, grab a AutoML block. We can put this in here and say acceptance is my target variable. We have features here, and I'm going to remove those two that I promised that were bad. We have a standard set of tasks and metrics to optimize over. And importantly, Einblick here also allows you to specify how long I want to search for. With this idea in mind of the fact that you should be sitting down, rapidly iterating, collaborating, getting to an answer, and sometimes that actual initial answer satisfies everyone is good enough. Sometimes that initial answer needs to be taken and evolved on. We have this ability to kind of say, we'll return models to you right away within 2 seconds. We can continue to search, but as you sit down with the folks on your team, actually what you really care about most is these Shapley values in the explainer. And to somebody who is not trying to build a model, not trying to figure out what hyperparameters you use, or the fact that we used XGBoost here with this set of pre-processing steps, actually there's a valuable conversation to be had immediately saying, incentive is the top variable, remaining length is the second most top variable, age is the third. Does that make sense? On the other hand, we see employment and marriage does not matter. Does that also make sense? In every situation, the discussion around which top variables exist is actually going to be most important. In the past life, I was working with a number of apparel retailers, and we were building this model to forecast store closures. The most important thing we did every time was we had to reserve 2 meetings, right? The first meeting was to present the model variables to the leadership team. Everyone had their day in the sun, gave feedback. Then 2 weeks later, we would go and have a second meeting and present the final model, which more or less would resemble the first one, because we had done our due diligence. But it's important to get the feedback from everyone. And even that feedback step is additive over the traditional approach of building a model in secret, in your cave, and then showing up with a PowerPoint. So then, in the background, it has continue to search and continue to search. And from here, we could take this a couple of different ways. The first is, we also offer you the ability to, export either a Python file or a pickle file so that you can continue to use it elsewhere. You can also deploy models in Einblick itself. We allow you to, take this executor, which is really just the pickle, I think I just dropped from internet. So from there, we would take it and allow you to, I'm just going to upload the CSV instead of reconnecting. So from there, we would allow you to deploy it in Einblick, write it to database, a very standard set of operations that you would expect from a deployment method, or you can take it to go. We also offer you the ability to have a set of acceleration of deployment through like dashboards, and you can embed these dashboards and iframes or put them wherever you want. And so it's very flexible. We want Einblick to be a workspace that you can come into, build a model with your stakeholders, explore your data set, have that conversation. And after that, if the initial draft prototype makes sense, then we can go with that one. So recently, we built a model to take product telemetry and website usage and predict who would answer a sales email. Doesn't need to be the most accurate model in the world, doesn't need to have a PhD work on it for 3 months. So then we can take that and deploy it to a dashboard right away. Other situations, you explore the variables, it's mission critical. You're going to continue to work on it, but at least you've had that initial ground truth conversation with folks, and you have somewhere to begin.
Thank you so much. My question is around, you've explained how this can be used for exploration and also for execution. What about like deploying into production? Is that something that sort of you see as outside of scope and you download the pickle and then you take it yourself, or is that somewhere that you all want to expand into?
Yeah, so I think there's some things that are already inbuilt, right? So for instance, we can run it through the executor that I was showing before we had the little accident. You can take that and either push data back to the database source that it's from, right back to database. You can put a new data set into that executor, put that on a scheduler, and then the whole thing into a dashboard. So there's some simple things you can do to productionalize data. Also, the reason for the pickle and the export isn't necessarily that we want you to take it away, but the fact that it makes people much unhappier to not be able to take it away, right? The goal is to put that button there and have no one ever use it. And that's kind of the design principle of that one. But if you wanted to just kind of take a look at the model in the platform, you're always welcome to put a new data set in here, and it comes out as an executor. And you see that there's a predicted accepted column that we can then visualize. And you can even explore how actual acceptance relates to that through this. And I'm doing a demo, so this is a phenomenal model.
Thank you. That makes sense. Cool.
Oh, shoot. And we also have other things that stand in between machine learning and exploratory data analysis. So for instance, a common one that folks really like to use is called key driver analysis. What this allows you to do is profile two populations, right? You're always looking at good versus evil in data science, and we have two populations: those who accepted an offer, who didn't; customers who churned and didn't; manufacturing devices that break and don't; or even just two vintages of customers, last year's versus this year's. So what we can do is to kind of bring these two populations together in key driver analysis and say, hey, like, how do these look different from each other? Especially when talking with folks who maybe think machine learning is scary and will kill Sarah Connor, or with folks who don't need a machine learning model and just need simple insights, you can actually come here and say, what are the differences in these two populations? We'll do some automatic bucketing, and you'll see that folks from age 39 to 52 make up 43% of the accepted population, just a quarter of the not accepted population. So first of all, that seems to indicate that that is an age range that leads to acceptance. But the simpler explanation here is also, if I were running a marketing promotion and it cost me money to do mailers or something like that, it cost per head, I could eliminate everyone who wasn't in age 39 to 52. That would eliminate 75% of my, 75% of my non-responders, but only 60% of my responders, right, or 55. And so just that simple optimization could save me a lot of money at the one variable level. And then obviously we have the ability to kind of increase the number of bins and increase the number of drivers interacted together. And so this kind of data mining approach is to walk from that one variable visual analysis of saying like, hey, like, how does my acceptance vary if I draw a line between another variable to it as a, for instance, I can come here and say, how does age relate to it? How does age relate to it, right? So I can take a look at this and interactively visualize this. I can go from that one visualization to this kind of approach, and then go from this approach to maybe correlation, and then from correlation to AutoML. And that walk from simple to complex in a kind of interactive way is, once again, the model we're trying to kind of approach data science with. Any other questions? In that case, I might show you guys one last thing. The thing that Einblick also offers you the ability to do is to extend the platform. If you have Python that you want to write, encapsulate, and deploy as features in the platform, you have the ability to kind of come into Einblick and actually specify a couple of parameters on the side. You see that we have some parameters defined here, and then you can actually write the code or import code from a Git repository, sync it in, and by doing this, what we've done is parameterize the function, and by publishing this in Einblick, you now can reuse that over and over again as a module within extensions. So what that means is that if you have either folks who are technical, collaborating with maybe non-data science data analysts, you can deploy features that way or collaborate by unveiling new functionality. You also have the ability to kind of bring in your Git notebooks or functions and scripts that you've already developed, even models that you've developed outside of Einblick, and deploy them as little modules here. So a simple data pipeline that maybe you trained a model on your home computer, and it's just a little script in PyCharm, you can put it in here and then use this kind of module to do a quick deployment. So put a data set on a scheduler and write it back to database. And so we do have some folks who just use it as a simple pipelining operational tool. Any other questions from folks? Cool. Timing got thrown off a little bit, I think, because of the late start, but I think that about concludes the presentation. If you guys have any questions, you can always find us at einblick.ai, or email me at py.einblick.ai. Check us out. Oh, question?
Hey, thanks so much. So I want to understand when you design this product, uh, what persona you keep in mind. Who do you optimize it for? Given it's a no code kind of a solution, so do you look for business users who want to make data driven decision making, or what's your mental model? Or
So I think our persona is relatively flexible. I think one of the things that we've noticed is like there's two components to code to data science that we've kind of bound together by accident. There's the writing code, and then there's all the other concepts. What's the difference between accuracy, precision, and recall? What situations would you want to use one of these things? That second concept is not replaceable, right? And I think a lot of the ways that no code has gotten it wrong is to pretend that you don't need to teach that concept, and you also don't need to code. So the collaboration approach is trying to say like actually there's knowledge that is already in different people, and if we can bring them together, you can unify it. So specifically to your question about personas, what we've seen work most frequently is a data scientist who works with a lot of stakeholders, right? You can imagine someone who's very adjacent to the business line. You can imagine someone at a startup. There's a lot of data scientists out there that answer to more stakeholders than they have teammates. And in that situation, it really behooves them to develop and to communicate in a way that is external first. In terms of like developing data science expertise outside of just previously trained data scientists, I think that's also possible. We've also seen that work. But that really works well when the person also has a desire to learn data science. And that situation actually works because what we've done is segregate the need to code from the need to do data science concepts. It's kind of like learning to play tennis, but right now all the teachers of tennis speak Japanese, right? And it's like you actually need to speak this whole different language in order to learn all the concepts, but that's actually not strictly true. And so I'd say that the main persona is that person with some knowledge and expertise, and what we're trying to do is bridge different communities together and offer some acceleration tools. That being said, by encapsulating some things in no code, we do make it easier for someone aspiring to learn more concepts to learn those concepts without the overhead of syntax errors at the same time.
got it. Thank you.
Hi, thank you. Could you give a sense of what the pricing for this kind of tool looks like? And just curious about that.
Yeah, so we have a couple different models. We have a version where we host for you. And so if you actually go to our website, it's entirely free to sign up for and use at the starter level. And you can connect your Databricks instance or you upload a CSV file and try it out. So we offer pricing per seat. It's, I think, $100 per user per month right now with obvious levers. And then we also offer an approach, much like Databricks, to deploy it into your, actually, we really like that model. And we can deploy into your machines. And the control layer kind of sits outside. And we're calling it a cube model. That one comes with a per machine licensing fee. And then we go from there. Into, I don't know. We work with the Defense Department a little bit, black boxes that are air gapped, and prices go up with that.
Thank you. I was looking at your website, and it mentioned the free level. I'm from academia, so I was wondering for students, how much data could you put into sort of the free level that's hooking, say, to the community edition of Databricks?
So I don't have the exact numbers off the top of my head, but I do know that we have partnerships with academic institutions and nonprofits. I'm actually not a sales guy, so I can't quote exact numbers to you, but I know it's anywhere between very cheap and nothing at all. I just don't want to come out and say free to anyone and have someone be upset on the other side, but we partner with a number of other academic institutions. And at the core, our entire founding team was like a lab at Brown and MIT. So if it's for an academic purpose or for students, I think we're very flexible.
Okay. Can I get a contact from you for for that?
Yeah, sure.
Okay, thanks.
Thank you guys so much for listening and coming here and checking us out. Definitely look us up online, try our product. We're always looking for feedback, and very excited to see how you guys might start using us to collaborate with other stakeholders.